Do I have a chat? Hey guys, what is up? Let me have a look. What is going on here? What is up, guys? What is up? So tonight is Friday night. We will be solving elite code questions. Elite code questions for a while. Shit is taking like 30% of my CPU. One thing I really don't like about this is like, ah, how do I? Hey guys, can you hear me? This is so wacky. This stream is so wacky. All right, so this is the problem we're kind of on. Uh, it's kind of easy problem. I have not lead coded in a while. I've not lead coded in a while, so we might struggle a bit. We might even struggle with like easy questions. But be on hold. Uh, but yeah, let's try it. I feel like we need to lead code. It's been very long, so I need to kind of get my algorithm set a little bit right. I need give it okay. I need to open my windows. Come on, my fan's going off, so it's like a laptop fan is literally just going off. So guys, I might just use my earphones because this is my YouTube music. Actually, can we? Because we're not okay. Let's just solve this. Okay, so we need to find a pivot index, and if it's not, Okay, let's think of the simplest case. How we can solve this. I'm assuming that every we're in a pivot index. So we need to sum at that point. So like for example, pivot index is 3, so 0, 1, 2, 2, 3, 6 here. Everything above this and this is so 11. This is 10, 11. What the fuck? And then everything above it is 11. So okay, that makes sense. So I guess these two would be the edge cases. Wait, why is this pivot index is 0? Oh, okay. It's 0 because you have 0 to the left. And then 0 over here. Cool. Yeah, I kind of get what the problem is trying to say. How do we implement this? So at every point we gotta check the left sum and right sum. So every index we kind of calculate this. So maybe what we can do is like for I enumerate nums. What we can do is, okay, so let's check nums I, so till that point, I guess. Everything that's till point, okay, till sum till everything that's till point, and sum till nums 0 I plus 1. Okay. Yeah. So let's call it mask. I know. And then we basically we gotta return the first pivot index, so which is okay, what's the first? Okay, I guess like there's an edge case for the first one. The first one would be what? So in this case, right, like in the case of 2, 1, minus 1, what would it be like? The very first element. You would kind of go over here. You take some. I think that would give you an empty array. Yeah, I think that works. Actually, you don't even need to do this. Okay, index. All right. What am I trying to do here? We're trying to return the index. Okay, range num. Okay, range num. Okay, cool. I think that's. We don't need index here now. We just basically need for that particular pointer. For this particular pointer, get the sum, get the thing. I mean, what, can we not just do this? Like, or am I just overthinking this? Sum of if sum of nums I why is it like yeah, that return I, right? So we don't even need to do that. Actually, can we do this? Let's do I. And then kind of return res here like that. Yeah, so something like that. Solution index. Let's try this. Okay. So 3. Okay, Python 74. Okay. Oh, it works. Great. Okay, let's try running this. I think it's too slow. Yeah, too slow. So we need to kind of speed things up. All right, okay, how can we speed things up here? How can we speed things up here, guys? Firstly, I'm pretty sure. Can we try this? 1, 2, 3, and -1. Does that work? Yep, it works. Wait, nah. It really doesn't work. Okay, hold on. Let's print this out. What is the solution? -1. 4. Yeah, it works. Okay, cool. It works. We just need to speed things up here. Okay, so we need to trade off time with speed, time with space. Okay, how can we trade time and space here? So we need to kind of store something. I feel like either this is too slow. This is too slow. Okay, cool. Why is it too slow? Because we're looping over everything. How would you know without looping? So we do have to loop over it. Maybe the summation part is kind of slow. Summing, because yeah, summing would take you. You have to sum everything. But if we, all right, let's go through this example. Like 1, 7, 3, 6, 5, 6. What can we store? Well, we can kind of go like, okay, 1. We can check. Well, we need to check the. We need to check if this sum. We need to find out this particular sum. Okay, and for this we need to find out this particular sum. Interesting. Do you see there's like overlap over here? I'm not overthinking this, but like, do you see this? Like for 6 you need to find the sum of 7, 3, 6, 5, and for 1 you need to find the sum of 7, 3, 6, 5, but 6. Interesting. I just feel like there's work being done over here. Double work being done over here. 7, 3, 5, 6 is being summed twice. Interesting. Okay. To be honest, I'm really not quite sure. What can we save though? Like, can we save the sum of the consecutive numbers? If we save 1, 7, some of these, and then some of these, some of these, some of these, some of these. Then you would have like what we have. We have 1 plus 7, and then 1 plus 7 plus 6 plus 6, and then you have like 1 plus 7 plus 6 plus 5 plus 5 plus 6, like that. You have that. Is that useful anyway? I guess you can just subtract it, can you not? Like, so some of this would be like this, like for 1, the sum of this for 1, literally go over here and subtract it by 0 by itself, so it would be like 0, and for the right hand side, for the right hand side, how would you get the sum? Well, you need to go all the way up here and subtract it by 1. I think. Yeah, so like for 1, when I equals to 1, well, what we need to do is like I'm just playing around here. Check this. Check this, I guess. Hold on. So if this is like the nums array, right? Like this is the nums array. Cumulative cum nums. If this is cum, right? Then you gotta do this, and then that would be referring to that thing, and then myself. So it's almost like this. I'm not quite sure. I don't see the pattern. I'm just kind of logically deriving. I think I'm just trying different things out. So it would be like cum sum minus 1. Minus 1, that would be that. And then you... Would it work for 2 though? So when if you got 2... No. Okay, no. Okay, wait, hold on. It's not I. I is the index. I think it will be like this. Nums I like that. And then when we can have like, let's just do a thing, and then let's see if we can come up with a pattern here. Okay, so I equals to 1. So I'm proposing that for any I, this is I equals to 1 G, like geez, G. Okay, hold on. God damn it. Okay, so it would be like what over here? Come some, so that would be like 1 minus 1. And then you have this is not come, this is and then you would have like your, well, that would be 7 plus 6 plus 5 plus, that's 12 plus 5 is 17 plus 1, 17 plus 17, 17 plus 17, 17 plus 7 is what, 24, 25. So it'd be like, my point is that you would have this particular equation, I think, right? Which makes sense, right? Which makes sense. And on the other hand, you would have like this particular equation. Okay, cool. And we will be checking this one. One. No, it will be 3, 6, 5, 6. You take something 3, 6, 5, 6. No, it's actually wrong. It's actually wrong. Wait, what am I going on here? 1 plus 7 plus. But I think I'm in the correct idea. Okay, so looks like you need to 3 plus 6 5 6. We definitely don't have that here because okay, looks like we need a particular variable. Looks like this. So left, isn't that just one? We need to calculate certain things. So like 1 plus 7 plus 6. Bro, I'm suck at this. I've not done this in a while. So 3 like that, and then we also need to kind of go 7 plus 3 plus 6 plus 5 plus 6. Yeah, and then so on till we get till we just get 6. And then on the right hand side we get on the right hand side we get 1 da 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 da. On the right hand side we get it's sum to the left. Okay, this is sum to the left. This is sum to the right. Okay, 1 plus 7 plus 6. 3 plus 6 plus 5. Okay, like this is what we get. And then for each index we just check. Okay, let's try this. Okay, let's try this. But I feel like it's the same though. I feel like the complexity wise it's the same. For I nums to go like, yeah, which is I just have a feeling that it's same. I plus 1. Okay, this is sum to the right. Sum to right. This is I plus 1. I is to get to the nums, and then you gotta do that. Sum to the right. Yeah. Cool. And for I in range cat. Okay, cool. What we gotta do is like just check sum to the left I, does it equal to sum to the right I? If sum to the I, okay, return I. Okay. L. Okay. Otherwise, return -1. Okay, cool. Does it work? Oh. Is it not? Is it? Ah. nums, right? Nums. Okay, let's test this out. Just right. Okay. Yeah. Okay, let's try. Okay, cool. It works. Let's paste this here and submit it. Hopefully, we get it in time. Nope. It's easy. It's an easy problem, guys. It's an easy problem. We still can't solve this. Oh my god. All right, let's think this through. What else can we do, guys? We're not gonna give up here. Okay. By the way, is the stream just still alive? Guys, watching myself stream is like kind of hard. All right, guys. I'm just gonna zoom this in so you guys can see this. All right, let's think this through. Obviously, this is not the optimal solution. We don't even pass this. Man, this is so demoralizing. Okay, what can we do? Let's have a look. The problem is we're calling sums too many times. We don't want to call sums too many times. So I think what we can do is like, is okay. Another idea is to kind of add up the things as we go. So 6, 5, 6, right? We can just kind of add up as we go. So 1 plus 7, yeah, and then but not only that, what we're gonna do is like we're going to, so for this particular value, right? So imagine res, right? For this particular value, what we're gonna do is like res, okay. Imagine this is the location I minus 1 plus res I. Something like this. Okay, let's try the idea. So the idea is like not to like sum the entire bit, but just sum to the left. So all right, okay, let me okay. Sum to left might be equal to actually, can we start with like empty thing? I might overthinking this for I if I equals to 0, then sum to the left I, like that. Else, what we can do is get the last one, and then kind of go like that. Like that. That'll be sum to left. Sum to right. Well, sum to right would be. I don't even know. This is an idea that. Okay, this might not work. But you can see over here, right? This is just. This is just. Right, G. Okay, cool. Okay, cool. Actually, no, not really. Sum to right. Okay. To left and then sum to right. Wait, what am I doing here? Okay, what? So you got one. Wow, that is not right. That is definitely not right. That's definitely not right. This is. Why am I struggling with easy questions? To be fair, I've not done this in a while, so it's like need some warm up before. All right. The solutions I came up with is it takes too long. So how can we make it fast? I have no idea. I'm assuming it's over here. I mean, the possible solution is to kind of go over each index, right? And then kind of loop over it. Like each index, you find the sum to the left, sum to the right, check it, and okay, what is the total sum though? Like, you got a total sum, right? Total sum, which would be 1 plus 7 plus da 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 plus 6, right? Okay, and if you want to find out the sum to the left, is there any more constraints that I'm not aware of? Yo, am I missing something here? 1 plus 7 plus 3. Okay, the thing is, like, what needs to be improved here, though? I tried doing that whole thing. You're pretty much summing over this a lot of times. There's pretty much duplication. There's a lot of duplication here. Duplication of summations. Oh my god. Wait, I'm thinking some stupid ass solution. Like, I think, what you can do. Oh my god, this is so easy, dude. This is so easy. Okay, so I think what we can do is like, so take a look at this, right? So for this case, oh my god, the total sum is this, right? Which is what? Which is, I don't know what, like 5. Okay, 12 plus 5, 17, 10, 11, right? So total sum is 11. Okay, pivot is 6. We know the answer is pivot is 6, right? So what I'm trying to say is pivot is 6. So which means 11 minus 6 is what? 5? Wait, what am I thinking here? $21. So okay, so what I'm trying to say is here 11, 6, 11, right? So if you sum this up, right, which is no, this is not 11, man. This is, let's look. 22 plus 6, 8, 28, right? Which is what? 28 equals to what? 28 equals to this, right? Which means like we can kind of rearrange it like this, right? Which means if it is divisible by 2 after subtracting it by subtracting it by the ith value that you're trying to check, if it is divisible by 2, then you got the pivot point. Oh my god, that is so easy, bro. All right, let's implement this. I don't know why I didn't see that through though. I don't know why. Yeah, I didn't see that. Okay, total sum of nums. That is the total. If total modulo is 2. Actually, hold on. For I in range nums, actually len nums. Okay. Okay, let's get the pivot value. Okay, let's get the pivot value, which is nums I, right? And what we're trying to say is, if pivot value, actually, total minus pivot value, divisible by 2, then return I. If nothing works, then return -1. Let's try. Oh, what is this? Huh? Oh, I didn't save it. Sorry, my bad. Oh, no. Nah. What? It didn't work? Come on. Come on. I thought it works. 1. What do you mean? How do you get 1? So over here, it thinks it's a proof value. It's divisible by 2. It's 1. Like, why does it return me 1? Okay, so let's think this through. If it returns me, this is the value, which doesn't make sense because your total would be, in this case, your total would be like 3, 6, yeah, and then you 6 subtracted by 2, which would leave you 4. God, no! It doesn't work. No. It doesn't work. This is interesting. Oh, I thought I found the answer. I thought I found the solution, dog. Alright, no, it doesn't. It's not like that. Yeah, I totally forgot about it. Yeah, I totally forgot the fact that it's... Huh, why doesn't it work? Because you can have 3 in that side, 1 in that side, but you need 2. Huh. Oh, I thought I found the answer. Oh. God damn it, I thought I solved this, but nope, it doesn't work, guys. Just because it's 4 doesn't mean it's equally divided in both sides. You could have like 1 and 3, right? That's not, left and right is not equal. That's still 4. So you could have a pip, like what I'm trying to say is like, this is a clear example of why it doesn't work. The sum is... Yeah, how do you solve this? Literally, how do you solve this? Why am I struggling with an easy answer? Easy question. God damn it. Alright, well, this doesn't work. Back to the drawing board. Can we solve for this? Like manually? 1, 2, 3. It shouldn't be that hard. Literally. Oh. Okay, 1. Literally, I would just kind of check left and right, and then if they're equal. But that's it says you can't. Guys, I will have to solve this before I go to bed tonight. 1736. Okay, let's try to solve this manually. Okay, how will you check this? You check everything to the left and then everything to the right. Is it possible we can use like multiple pointers? I have no idea, guys. Like, how the hell do you do this? Yo, it's an easy question, guys. It's an easy question. It's an easy question. Find pivot index. Ooh, I'm guessing out loud here, dude. Let's try to think this through. All right, let's try to write the naive solution. Like, let's try to write a naive solution and then optimize from there. All right. Yeah. Fine. For each index, let's find a sum to like. Let's try to. I actually forgot the naive solution. Let's try to write the naive, like the basic solution. Doesn't matter what the time is, and then we can optimize from there. Okay. Sum to left. So I'm gonna like really break each code down so we can. I plus 1 and then sum. Right. Okay, like that. Okay, and if I mean, I guess this is the most naive solution. I mean, this has to be like the most naive solution. All right, let's just try this out. Let me see if I. Guys, obviously the time it takes. Oh, what? Why am I? How? You got accepted? I don't get it though. Okay, that is the naive solution. To be honest, like I'm curious to. Okay, well, the goal was to just to find a solution to get accepted. But I'm not quite sure like why it failed the first time around. Yeah, not quite sure. It beats. Okay, in terms of memory, it beats like 99%. In terms of runtime, not really. Uh, Honestly, like I'm not quite sure. All right, let's go to the discussion session. Oh my god. Oh yeah, that is so true though. That is so true though. That is so true. If you know, basically I was in the correct direction. Instead of division, I should have thought like subtracting. Oh yeah, that is so true. We only need to know the sum to the left. We don't actually need to know. All right, so let's try to amend our solution a little bit here. The only thing what we can do is here is like weeks. Some nums. The only thing we can do over here is total minus sum to the left minus nums I. Yeah, sum to the right, and then that should bump our runtime like complexity on this particular question. Right. Okay. Let's try this. Quick question: how satisfied are you with new? Okay. Let's just say continue. Okay. Submit this. Submit this. What? I'm still quite slow. I'm still quite slow. I mean, that's the idea. Like, if you know the sum to the left, then you know the sum to the right automatically. If you have the total, which I don't really understand. Hold on, let's have that. Oh, I see. So you're like, oh my god, the fact that it uses all my ideas, like all the ideas I have so far, it's literally combined into one answer. You have to use everything. That is interesting. That is interesting. So you keep it. So not only keep it tally to the total, but you basically you keep as you go through. Basically, as we go through this pointer, right? As we go through this pointer, as we put the pointer, we can discard whatever happened. We store the sum. We store the sum. We store like some information from previous computation. So imagine if pointer was I equals to 1, right? I equals to 1. Imagine I equals to 1. We store some information so that that can be used in later purposes. So I equals to 1, sum to the right, right? And sum to the left of I. Yeah. I equals to, I don't know. Actually, let's do sum to the right, I think. Basically, the idea is to kind of like keep. Okay, this is really good. I like live streaming this because I will have to articulate this. I will have a reason to articulate like my thoughts, which is really good. It forces me to do that. Okay, sum to the right. We need to store some bit of information from previous, so we can use that signal, previous, like information to kind of help with our current competition, which is kind of like dynamic programming, like sort of, not quite really, but just the fact that we're storing something, kind of like is a good thing. Yeah, sum to the right is say 0, right? I think. Okay, for I equals to 2, sum to right. Okay, sum to right equals to what? I equals to 1 plus sum to right 2, right? Basically this is what we want to store, and if you kind of generalize this a bit, n would be like 1 plus, I don't know, like sum to left, 2, right, and then dot 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 dot, and then plus sum to left. Sum to right. What am I doing, man? What am I doing? Left to left. Like n, right? So the idea is, I think the idea is like we want to store, the novel idea is like we want to store you can see there's like a lot of repeating work happening, right? Like 3. You can see there's like a lot of repeating work happening, right? There's a lot of repeating work happening. So we want to basically store the whole thing, arguably. Yeah, we want to do that. I think it's a good pattern to kind of notice here, like not just the idea of like pattern, like the idea of storing stuff is not quite important. I feel like as the visual stuff over here, me just drawing this out, like anytime I will see this particular pattern like laid out, like written like this, then I can instantly like know that, oh, I just have to store, you know, certain things. Like, so okay, let's implement this. Okay, sum to right equals to, I think starts with 0. Sum to okay, I'll have to kind of amend this. Okay, so, sum to right is first 0. Okay. Sum to right. Okay, so you gotta start off with sum to right equals to what? 0 of what? Sum to right of the first character is 0. Let's start from second character, alright? Second indices, which is sum to right so far plus what though? Actually, you see over here, I'm actually wrong. Wait, am I? I thought I understood this. Why do I more think about this? Okay, hold on. Wait, steps. Yo, I'm just talking too much. Okay, I just wanna like look at the answer a little bit. Okay, it's got the total minus the left sum minus I. That's then that, and then nums I, like that. I think, I don't know. So you start off with 0, and then you start off with 0, and then start off with 1. God, this is an easy question. Why is it taking me an hour to finish this? Shouldn't this be that though? Oh yeah, actually no. Shouldn't be that. I know that. This is funny. Guys, I suck at leak coding. So it's fine. We get better. Huh. Okay, I know this is the answer, but why? So we're over here. We're calculating some left for the next guy. So there's why are we adding? Oh right, I see. Because we're only adding the next guy. Yeah. Okay. Cool. The thing is, like, is there a pattern I can see, like, for? So, guys, okay, is there a pattern I can see? So how do we, like, what about this picture? What about this particular image gives it away that gives away the fact that we are going to send something? Huh. This is why I really don't like looking at the answers. Because now, like, I'm not even working hard to kind of like find, like, create these visuals. Um, I mean, I get it. Like, that's the algorithm. Okay, cool. There's a clever thing that I had to kind of figure out. Once you know the left sum, you can kind of find out the right sum. But I'm more interested into kind of like seeing like how I can kind of how can I kind of know that this particular gives it away. And it's definitely a pattern here. Like you can see like a half the triangle being calculated. I've seen this pattern somewhere before. Uh, it's almost like a diagonal. Like you imagine a cube. Ah, interesting. Imagine a square, right? And you cut off that square in a diagonal. That this is the pattern you get. It's almost like saying calculate the diagonal scores. I don't know. 0, 1, and then okay for this for I3 we know I this thing uh, it needs this particular 0 plus 1 in this thing. So from I2 this particular signal needs to get propagated to I3. Um, I think this is what we're doing over here. Right? And so on. It's a recursive thing. Um, cool. I think that's pretty much it, really. Yep. Okay, the signal. This okay, cool. That's the signal you want to get passed through um, every time. Signal from previous, you add something and then you pass it to the next signal. Okay, cool. Yeah, I get it. I get it. Um, yeah, I get it. So basically, you're just passing signals around. Cool. Um, all right. Okay, let's try it. Does it even work? All right, guys. That's that. Uh, I'll be trying more questions tomorrow. Uh, Well, why do I have so many notifications? Split liquid. Damn, someone. Oh my god, someone's actually good. Like it's good, kind of good to kind of do this. Mount Premium. Someone give me Premium, please. Let's see. I've solved a lot of questions. Not a lot of questions, but progress. Oh, can we not see how many questions we solved? Let's see how many questions. I thought I solved more. Why would someone? Okay, cool. 167, 57 solved. Most of them are. To be honest, I've not been consistent, so. Damn, my rank. We need to work on this rank, yo. Oh my god, my repetition is. Dude, solution 8. We need to solve more SQL questions. Not gonna lie. Alright, guys. I think that's it for today. I need to kind of go have dinner and then. Get pushed. Okay, cool. Yeah. Okay, that's it for today. That's good. I don't know. Alright, guys. Ciao. Peace. Have a good weekend. I'll probably see you tomorrow.